Hello world! Welcome back to this tutorial on Linux kernel programming. In the last video we've written a little kernel module, and in the next video I want to turn that kernel module into a driver for an external device. And right now I don't have such an external device. So that's why I'm making this video, because in this video we will just build a little external device. This is one of my Raspberry Pis, and I've talked about Raspberry Pis in the past. I really like these little things because they are so small, but they are still complete computers. So you can install a Linux system on it and then run your Apache web server, or you can run file servers, whatever. And you have an Ethernet connection here, so you can connect it to your network. And then you plug it in, and of course it will take a little bit to boot, but then it will run and you can connect to it through your network with SSH or other means. And another thing I really like about Raspberry Pis are these pins down here, because these GPIO pins can be controlled from your software, which is really an interesting and useful feature. And the arrangement of these pins exactly matches this IDE cable. So IDE cables were more in fashion in the past for connecting to hard drives, but I'm using them in connection with this little thing here. This is an adapter that has an IDE port here, so we can just connect that cable to this adapter and connect the other side to the Raspberry Pi. Okay. And on the other side of this adapter we just have these pins which fit this breadboard. So you can plug this into a breadboard, and now these GPIO pins are basically just connected to these rails on the breadboard. I guess that you already know breadboards, but in case you don't, on a breadboard you have these rails here. So this is the plus rail, and all these holes on that rail are electrically connected, and all the holes on the minus rail are also electrically connected, but the holes on the minus rail are not connected to the holes on the plus rail, and so on. And we have the same thing again over here, and then we have these rows, and the holes on the rows are also connected. So these holes are connected, but the holes on the other side of this gap are not connected to the ones over here. So they are connected to each other, but not across that gap. Okay, now what I like to do with that is I would normally take this little red jumper wire, put that into the connect that to this GPIO pin that always has 3.3 volts, and then connect that to this plus rail. And here on the other side I would go to the third row and connect that to the minus, because that's a ground pin on the Raspberry. Okay, and now I will take this little thing here, that's a so-called buzzer, and I will just plug that into the last row here. And yeah, I've plugged it in such that one of the pins is on this side and the other pin is on this side. So now I can just connect that to the minus rail. So that it's connected to the ground of the Raspberry Pi. So if I put voltage on that, then it will work. Let me just demonstrate that. If I go to the plus here. Okay. And now I take this 220 ohm resistor and use that to connect that last row to row number 26. So let's test this. If I connect this row number 26 to the plus rail, well, then this buzzer makes this very annoying sound. Of course, you don't want it to be this annoying and make that sound all the time, so you would normally not connect a buzzer to a constant source of electricity. So instead, I will connect it to one of these GPIO pins. And yeah, the sixth pin on this side is the GPIO pin 17. And now I can control this buzzer using that GPIO pin. And now I will duplicate the same circuit on a different pin. So I will take another 220 ohm resistor. And yeah, since that breadboard here is quite small, I will put it directly here. Without another wire in between. Oops. Okay, I hope that didn't break. Instead of a buzzer, I will use an LED. And let's test if that works. Okay, it turned on. So I'm gonna put this on pin number 15. Okay, so this little external device is now not connected to my laptop here. It's connected to the Raspberry Pi. So yeah, that's not a big problem. I will just copy this whole directory to my Raspberry Pi. Okay. And then I will connect to that Raspberry Pi. Okay. Okay, so this compiled just the same on my Raspberry Pi. You might have already noticed that this is my kernel version here, and yeah, that's because I also compiled the kernel on my Raspberry Pi myself, and that's why I don't have any problems with kernel headers. On the Raspberry Pi, you can install the package Raspberry Pi kernel headers to get the kernel headers. I've had problems with this package because yeah, after I've updated the kernel, yeah, the kernel had a different version than the kernel headers here, and then I couldn't build kernel modules anymore. So that's why I then built my own kernel. And if you want to build your own kernel on a Raspberry Pi, you just go to raspberrypi.org, and down here we have the documentation, and in there you have Linux, kernel, building, and that's a quite short but very good documentation. It tells you which packages you need to install and what commands you give, and yeah, everything just worked smoothly. So really a good documentation if you ask me. So that's why this kernel module now built without any problems, and I can now do load the kernel module on my Raspberry Pi also. Okay. Now before I finish this video, I want to write a little function that I want to use in the next video, and I don't think it would be fitting to write it then because it's a bit complicated and not exactly part of the whole driver infrastructure. So okay, I have this list of Morse codes here. Okay, that's all I wanted to prepare for the next video. I think you can already see where this is going. Um, yeah, I think next time is going to be very interesting, so absolutely don't miss that. If you like this video, like it, share it, subscribe, and goodbye world.